I've been to Raspberry Pint, and I find myself presenting on the first time that we've had an in-person for 3 years. So I feel very privileged and honoured to be able to do that. So my name is Mark Jones, otherwise known as a Scuba Hacker. Hacker in the sense of the traditional sense of the word, as in someone who goes and finds things and repurposes them for other purposes, especially in the technology arena, rather than hacking banks and being a phone freak and things like that. So I'm a scuba diver, obviously, and I've recently rediscovered why I'm interested in tech. So I'm at that age, 46, where, been through a career for quite a long time in tech, and kind of forgotten some of the reasons why I got into it in the first place. Becoming an engineering manager, senior engineering manager, having been a computer engineer for over 15 years. And I think, what I was going to ask the room first, actually, and people online can just have a think about it, is put your hands up if you remember the time when you felt a real connection with technology to the point that you're here tonight at this meetup. So was there a certain computer, or was there a certain game, or was there a certain application or console which made you think, actually, this is really interesting. It's something which I want to spend a lot of time doing. So if you just put your hands up if you think you know what that is. So, and I bet a lot of people, that'll be if they've been in the UK and they're maybe of a certain age like me, 80s, 90s computers, Spectrums, Commodores, Ataris, Amigas, maybe a bit later on, PlayStations, Sega Mega Drives, Xboxes, Wii, Nintendo Wii. And the thing is about the 80s in particular, for kids, there was no barrier of entry to basically program computers without having to know anything about complex stuff. You could walk into WH Smith and type 10, print hello, or something a bit more rude, 20, go to 10, run away, and then you'd be just having that up on the screen. And so the relevance of that is, that's how I find Arduino coding. Because when you start doing that and you see that you've got two methods, setup and loop, and all of a sudden you see your very first example, flash an LED, obviously everyone's first project's got to be an LED project, it seems, and it was for me, is it's so simple. 90s, early 2000s, you were talking about 2G 9600 board. You didn't even have GPRS. It was a connection base. It's like having a modem, AT commands, 9600 board. That was the maximum you could get out of a mobile phone. They could all do that. But that was what you're dealing with. However, if you think about when you're doing Arduino projects, you're dealing with sensors, which are a small amount of data. 9600 board is still what GPSs use. Actually, 4800, a lot of them default to. So for doing GPS, you don't need much power. In fact, GPS is so simple. If you've never used one before, you have just an ASCII string. And each ASCII string is like they call it an NMEA sentence. It's readable. There's just a very good set of documentation about what they mean. And you don't even have to query it. It just starts. And it starts the moment it powers up and it says no fix to start with. And then when it has a fix, it sees where the satellite, well, it works out where the satellites are. You get a fix. So it's actually really easy and a really good way of sort of getting into location-based technology. So what I wanted to do was build a sat-nav for scuba diving, which let me go around this lake easily. And basically, my buddy and I could just decide at the beginning where we're going to go. And when we're underwater, it will guide us, go on this heading of 100 degrees. You need to go 50 meters. And then as you're moving, it updates it. And you've got a digital compass on there, Adafruit sensor, which costs probably about £10, I think. Amazingly, because I didn't realize this, not only is it a magnetometer, but it's got an accelerometer, which means that you can tilt compensate. So if you if you have a real compass and you tilt it, it doesn't work properly, does it? It's the same for proper, for a digital compass. It needs to know what its attitude is in relation to gravity or the magnetic field of the Earth. So we've got a digital compass on there. That tells you in real time where you're pointing to. And then it will look at your course. So every 10, 20 seconds, it will look to see how far have you been and what course have you been on. So have you followed the 100-degree heading, which we've just instructed you to do? Anyway, so the point is just to have a bit of fun navigating around, and then when you've finished, you've done what you plan to do. So when you're scuba diving, one of the cardinal rules is you plan your dive and you dive your plan, because you want to be safe, you want to enjoy it, and you don't want to just be pootling around with no real aim in mind. So that's what it's for. However, the big thing is, wouldn't it be great if people who perhaps cannot see too well could do a similar thing? Now, there's dive charities who help people who are disabled, partially sighted, blind, paraplegics, people who've got such massive challenges which I cannot comprehend what it would be like to live with those conditions. But HSA helps people like who have these challenges to do things like scuba dive. So a dive doctor said to me when I said what I was doing, he said, well, if you can have audio, then someone who can't see very well, instead of them being trained to dive and having their hand held, they could be autonomous. And that means a lot to someone who is, who has an impairment, but wants to break through that and wants to be empowered to do the things which other people do. So if you think about it, someone who's blind or partially sighted, everywhere they go in the world, potentially they've got to have some way of getting through that world without colliding with things. So they might have a dog, they might have a helper. So underwater, it's not much different at the moment. You have an instructor, and somebody basically told me a story about someone who was almost totally blind, who said it was one of the most empowering experiences of his life, floating mid-water to scuba diving, because he could control his position in the water vertically by breathing in and breathing out without anybody interfering with his body and without having a worry about crashing into anything. And it was extremely relaxing. And, this is someone who does a lot of extreme sports despite his, his challenges. So make it audio capable. That was actually the real reason at the end. Instead of it just being a bit fun, let's try and do something which could really transform someone's life. So here we go. So Hackaday, I'm sure people on this call will have heard of it. For those who haven't, it's one of the best websites which basically an aggregator of open source projects for Arduino, Raspberry Pi, and all of these great physical computing and Internet of Things, projects and stuff which, I've been in tech for, well, if I consider I started at the age of 7, that's 39 years. But I get amazed by what people do in small amounts of code and the fact that it's all shared online. So I've come from a world of, yes, corporate IT and open source, but it's like Spectrum Commodore 64 days. You can understand it down to the last, oh, why is it doing that? Why is it throwing that error? Because you've got the code, but you don't have a massive operating system running in the background. Maybe a thin one with the ESP32, but certainly not really with the Arduino. So that's where this has come from. And basically, having sort of read hundreds of these projects, I came to the conclusion that we can do stuff like this. Emergency messaging. If I've got a cable coming down from the surface, which can take GPS signals down, then I can send telemetry back up. And okay, it's 9600 board I'm using. The only reason I'm doing that is because I'm basically lazy and I haven't wanted to terminate the cables with the resistors, but I don't need anything more than that. But what I know is if I do that simple thing at either end, I can probably multiply that by 10 if I want to. So emergency messaging. Well, how would we do that? Well, let's forget about the technology platform that we would use to connect to on the internet and say, where's my drive come from? My drive has come from the inspiration of seeing other people putting very simple projects on the internet and telling everyone how it works. So I found a Twitter one. Now, I thought, oh, that would be good. Imagine if I could just press a button underwater and send a tweet to maybe someone who's at the cafe at the dive site and say, can I have a bacon butty in 20 minutes? Because you could. But more importantly, you could have an emergency messaging system. Now, I'm not suggesting you use Twitter to do that, but it's the concept which is important. So found that I had that, I put it in my Evernote, made a note of it, came to the point where I thought, well, let's try it. So it took about 2 hours to do, and an hour and 50 of that was working out how do I deal with the Twitter API key. 10 minutes later, so 2 hours in, I was banned from Twitter. Because then I discovered that as a good engineer, what did I do? I put in messages at the beginning to say, Mercator origins online, and then the location message when I press the button. And the problem with Twitter is they've got all these rules which I wasn't aware of, like you mustn't send similar messages too often. And then they ban you for the API only, so you can still go on the website or app and send manually, but they don't tell you why you've been banned, and they don't tell you how long. So you go and find out, it's like, oh, it could be a few days. But it's probably most likely because I was sending test messages, and of course I wasn't moving, and it was all very similar. So Twitter's not the answer, but the point is it proves a point. You can easily send, if you can use your user interface, which is basically this, you have to have this down in the water. Now, in UK diving in particular, and anywhere else in the world where you've got currents, you have to have a smaller version of this spool with a string and a big buoy at the top so that someone who's driving the boat can know where to pick it from. And also, anyone else driving a boat knows not to hit you on the head when you're coming up. So we're used to having a spool with string. Now, actually, string's a tangle hazard. If you get string around your leg at 40 meters, that's bad news. So actually, this is using a cable, which is it's 4 millimeters thick. It's polyurethane, it's quite slick, it's quite resilient. So actually, it's less of a tangle hazard. And it's neutrally buoyant, which means that although it weighs quite a bit here, when you're underwater, displacement of water is roughly the same as the mass. So that means that actually it floats mid-water a lot of the time. So anyway, so emergency messaging, bone conductor. Well, this is where the dive doc really did pull something out of the hat. It's like, hang about, but dive doctor's talking about bone conductors. What is he talking about? So I didn't know this, but swimmers and runners can have headphones or earphones which just press against the temple instead of going in the ear. So his suggestion was, well, you could do that and it'd be a personal audio experience of the person instead of telling everybody in the vicinity which way to go. Because as I'm sure most of you know, water carries sound a lot further than air. So if you had more than one person being directed, that could well be very confusing. So that is a distinct possibility. I bought a bone conductor off either High Hut or Pimoroni for about £10. Of course, the challenge with that is I need a radio link. It needs to be wireless. I need a radio link underwater, and I need to pressure proof it. So that's kind of on the shelf. That's at the back of the drawer for lab work, really. Next one, bubble audio analysis. So these guys, these are M5 Stick C Plus made by M5 Stack, about £22.50 each. They pack an ESP32, which has got a load of built-in sensors. It's also got built Wi-Fi, Bluetooth. But that M5 Stack also rolls in microphone, a little buzzer, 6-axis accelerometer and gyroscope as well. So I thought, practice have a go in the swimming pool. So in Putney swimming pool on a dive training night, not just some random swim sesh. I took it in and I thought, right, okay, well, if one of these projects was basically put an oscilloscope view onto the screen of the M5. And the other one was a spectrum analysis, which I was amazed at that it could do a fast Fourier transform, because that's a serious amount of computation if I think back to the 80s and 90s. Anyway, so I had two of them going, and then you could see the fact that I could hear, it could pick up my breathing. So when you're scuba diving, you breathe in and it goes like a high frequency, and then when you breathe out, it's blah, 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 it's a low frequency. So you could see the difference in amplitude on the oscilloscope view, and you could see the difference in the frequency profile on the Fourier transform, which made me think, well, actually, these guys have got two 240 megahertz processors. And if you couldn't actually analyze it on board there, you could send a fingerprint of it up to the float, which is on the internet, and then use edge computing either in the box or use Amazon to actually analyze it and tell you what your breathing rate is. Why is that important? Well, if you've ever done meditation or mindfulness, you'll know that if someone's anxious, the best thing to do is just do breathing exercises. So even when you're a confident diver, when you first get in especially, your breathing rate's quite high. So it'd be good if you could be told, oh, okay, slow down. And also, here's basically the pattern which you need to follow. So that's what that stretch goal is, bubble analysis. And then the last one, integrate heart rate monitor. Well, if we could do a bone conductor thing, little did I know that I actually bought heart rate monitor for about £3. And it's just very similar to what's in the Fitbit. So why not? So basically what I've got to the point now where I've done, I don't know if people can see online, I've done real testing. So it actually works. I've done it in the lake at 10 meters, done it in the sea in Malta. I'm currently working on the audio module. So basically, you can see me here. I've got basically the module in my hand there. That's the console, which is showing basically a very basic display of which heading am I heading on. But today I bolted, well, not bolted, nanotape or gecko tape, which is my new favorite double-sided tape, which is such a geeky thing to say. Nanotape is this amazing gecko-like material, which has no glue, but it basically can bond two surfaces together with immense strength. And I can't, if I was trying to pull this off like this, 90 degrees, I wouldn't be able to. In fact, I tried doing it because I was rushing, taking it apart to get it off, to get it on the plane, half of it in my bag and half of it in the in my hand luggage, and it broke the wheel. So what you have to do is you have to leverage off, like a gecko foot, goes like this. So yeah, so I've got the second audio module on the side here. And there's no connection, no physical connection between the two. So the challenge is, at the moment, I've got this cable, GPS at the float, sends the data and the power, because I don't want any batteries down here to have to maintain or charge. And it's a very small volume. Send that information down, and then I want to create a noise. Well, a noise is going to be like 3 or 4 watts, and that's an amp or so at the voltages which we're talking about. That's a significant amount of current to send down a long cable because of resistance and losses. So I've got a separate lithium battery in there, rechargeable. We got a what's called a Beetle ESP32C3, which doesn't have a display, but it is capable of driving basically an audio amp using something called I2S, which basically means it can play WAV files without using any software. So effectively, it's hardware DMA access, so you can do loads of other stuff at the same time. So the idea of this is, well, I want the navigator, which at the moment is saying either, right, it will say, go on this heading, and it will also say, oh, you need to turn left with a graphic, or you're going to turn right with a graphic, or you need to go straight on. So all I need the audio thing to do is to either speak, turn left, turn right, go ahead, or someone who's blind or partially sighted might prefer tones. So low tone for left, high tone for right, beep, beep for straight on. Or maybe they might like to have vibration instead. So actually, there's not very much data I need to send between these two consoles. And if you have a look at my YouTube video, one of my YouTube videos, you'll see that I did a science experiment where I wanted to find out, does Wi-Fi go through water? And if it does, can it go through that distance, which is the middle of the cable? So the answer is, if I was using regular Wi-Fi, I don't think it would, because there's a lot of connection-based chatter which goes on with that. It has to be maintained. Long story short, ESP has got built into it something called ESP Now, and that's a proprietary Wi-Fi IoT-specific protocol using the same bandwidth, the same band as Wi-Fi, using the same channels, but evidently is permissioned by the radio authorities to operate on those bands, even though it's not official Wi-Fi standards. What that means is I can send bytes from one to the other up to 15 centimeters in water. and it's low power because it's not trying to maintain the connection all the time. So that was a surprise for me because I thought I was going to have to use light to communicate between the two because I didn't want to put an extra cable in. It's just going to get too complicated. How are we doing for time? Yeah? Okay. So the thing is, this is quite ad hoc because I started this project, then I find out that Hackaday's got a prize. So each year they do a prize where effectively you have 4 or 5 different categories where you take your project, you submit it, and as long as you put into Hackaday all of your information about what you're doing, then you get a chance to basically win prizes such as $50,000 first prize, $130,000 total prize fund. But actually, from a maker's point of view, okay, it's nice to have funds to do your making, but they also have, there's a company called Supply Frame who is very much involved in the Hackaday website. I don't know if they sponsorship, but they basically sponsor this prize. And they would give you a year's residence, which basically means all of the highly advanced equipment they use, you would have access to, presumably remotely as well as locally, if you happen to be in the area. So I recommend anybody who's, even when you're doing a little project, because people put in little projects, big projects, mega projects, and there's 3 categories left. So this was assistive tech, which was the deadline for today. And then the next one is called gearing up. And what that means is, for example, someone might want to create a tool which is going to make your making easier. So someone could create an oscilloscope, or maybe they could create a multimeter which can do capacitance and transistors, which it costs a bit more normally than it does to get volts and amps one. So gearing up, and then the next one is green tech. So anything to do with carbon reduction, anything to do with probably energy monitoring and things like that. That's the second category. And then the last category is called Save the World. So that is basically a wild card, and you can come up with anything you like, and you basically put your project online, and you follow the instructions. But you've got to basically fill your profile, you've got to put the instructions there. But basically, each of the categories, the assistive tech had 50 entries. 10 of them weren't assistive tech. People were just putting their projects in just to see if they could get away with it. So there's 10 sort of finalists from each category. And then those finalists then go on to the final round. So although I've done a lot of work to get to this point today, the project doesn't finish now. If I was to become a finalist, then they would say, okay, well, you've got to have a YouTube video, which I did. And then I did another 30 of them. The surprising thing is I've never done a video online before. And I did one because of this. And I thought, actually, what am I going to do? So I just did I thought, this is, someone else said this. The guy who owns the dive center, he sets the rules about what people can do there. He says, it's because it's my gaff, meaning I can set the rules because this is my project or this is my domain, and people are invited in and you can do reasonable things. So in other words, for me, I was like, right, well, if I'm doing a YouTube video, I'm just going to do something off the cuff. I'm just going to do something which was called the art, the science, and psychology of soldering. Now, what on earth is that about? You've got loads of soldering YouTube videos, but specifically to do soldering and stuff to go into this tiny console, which is GoPro enclosure, which costs £15. There's certain things which you've got to do, and you only learn it by trial and error, unless you've got someone else to sort of give you the tips and hints. So I started off with that, and that's had 170 views. I was like, wow, that's cool. If you go onto the YouTube, you'll find there's shorts as well. And so I thought, well, do a short, because some other YouTubers have complained in the past that the algorithm on YouTube promotes shorts, which are only up to 60 seconds, over their long form videos, which of course, especially monetization channels, they want to keep the eyeballs and they want to do their arse and have the long form. Anyway, so I thought, put a short on, and if I can get this to work, let's see. I'll just put that on just for some amusement value. So I've never done a video. Welcome to my channel. I'm Scuba Hacker. Mark Jones, ZX Spectrum. So, what am I doing? I'm building the world's most innovative dive telemetry and standard, and I welcome you on my journey. This is going to be something built by everything is open source, and I just want to take you through it and encourage anybody out there who dives and wants to improve their diving, get an amazing experience, to have a go at creating one yourselves. So, without further ado, have a look at the videos, and I'll see you on that side. Thanks. Right, so I wasn't planning on that, but so the very first short that I put on was this. And I just thought, let's just see what the algorithm does. Hey, Captain, there's a leak in the hold. Check it out. Hey, Captain, there's a leak in the hold. And within a day, less than a day, 12 hours, 19 views. I thought, what's the matter there? Anyway, the algorithm is deceptive because the first short you put on, it must blast the entire planet with your video. And to try and get you to do it more. Because every single video after that has never had 4 views. Barely, they might have 100 views, but that was the shortest I've done. The first I've done. Oh. Sorry. I was just saying that YouTube video, that short, was the first one I put on, and the algorithm went and blasted it out globally because I could see on the countries of people who were watching 1,900 views, and yet every other short I've ever done afterwards is only 50 or 100 maximum. So if you're ever doing YouTube stuff, just keep in mind how the algorithm's working and watch some of these YouTubers who know far more than I do to find out how you can help people reach out and actually view your content. So, cool, that's where we're going to go. So I'm not going to have much more time, I expect. So what I'm going to do is I'm just to say, this isn't just about computing. It's resilience mechanically, first and foremost. You've got to be waterproof. You've got to be able to knock it around. You can't afford to be able to, be precious about, oh, I can't drop it there. So for example, when I've got this in my hands, I can toss it in the water before I get in. Obviously not a current. But also, it's about mechanical engineering. So I've never done any mechanical engineering before. This was an open source project, which someone else has done. The question is, it's all very well me putting it in water and finding out that it doesn't leak. But what happens when we put it at 40 meters or 50 meters? Does the console, the GoPro enclosure, leak? And I'm not going to dive to 40 meters to find out, because you can only dive to 40 meters for 4 minutes before you have to come back up if you're on air. So what this is a pressure pot. The bit expensive, the filter, that's just a water filter. But then all the other bits are just brass connections. So what I can do is, there's a YouTube video that shows this. You can connect it up to an air supply, which for me was a 230 bar or 230 atmosphere cylinder, air cylinder. And then you put air into it, and then you look to see, does it have an unscheduled disassembly, or does it continue working? And, well, it continued working. And you put a pressure valve release on there, so you're not going to blow it up. And you sort of think, well, actually, it's probably going to work when I take it diving to 10 meters, if it's worked for half an hour at 46 meters inside here. So you actually fill it with water, then you put the device in there. I also put the yellow, where it says day after pressure pot test. That's my real scuba computer. Safety, my safety device effectively. And that can then tell you what's actually going on. So of course, I've got a device which I've built, and I don't know how accurate it is. I don't know if it's going to, collapse. But that thing's designed to go down to 60, 70 meters. So that was cool, because I've never done anything like that before. And again, it was an open source project, and I've acknowledged the person who's come up with that design, which I've tweaked a little bit in the Hackaday documentation. So I don't know if that's my time up, but basically, have a look at the Hackaday. Have a look at my GitHub if you like. Drop me a line on LinkedIn. It'd be just great to meet up with people. It'd be great to have a chat about your experiences, you know, not just with the Arduino and the ESP32 stuff, but also, you know, how you got into doing this and, you know, what we can do in the future, because, you know, some of the websites I've seen, like Crowd Supply, there's so much more down the line, which is coming on, you know, coming through the pipeline. The most interesting sensor I got recently was time of flight, which I'm sure some people know, you know, a lot of you might know anyway, but it allows me to measure between 2 millimeters and 6 meters distance, but it's multi-ranging. So if it's a bit like a laser pointer or laser pointer meter for your construction. I could point it at the wall there, and it could tell me how far the wall is. But if I put my hand in front of it, it'll also say you've got a second obstacle at this distance. And it's at millimeter accuracy. And it uses a laser, and then it's got a detector that can detect single photons. So imagine you're sending out your laser beam, which has got a slight divergence on it, and it detects some photons coming back quicker than others. And the quicker it comes back, the closer the obstacle. So I thought, well, actually, that's good for collision avoidance. Because if I've got someone who can't see, and they're holding this console like this, right? The part which is pointing down can tell them if they're going to hit the lake bed. And again, it's like, wow, didn't even know that existed. Again, no more than 10 pounds, 10, 12 pounds. So, yeah. I haven't yet. So basically the point it's got to, the audio module has been very challenging only because this Beetle ESP is fairly new and it's got real problems reading SD cards. And so I have it working. And the idea is I want to do a music test underwater. And then it'll be reading the card and then it can't mount it. And it's a proper SanDisk micro SD. I bought 2 different SD card readers, both Adafruit, one an older one, one a newer one. And both of them, it's sort of randomly failed. I even bought a new Beetle, which was only another tenner. And that one worked to start with, and that stopped working. So I'm going to have to go off to another microcontroller because I just want one without a screen. So I'll probably go to an M5 Atom or something similar to that. Anybody got any questions?
So, oh, there we go. Hopefully you can hear me online as well now. So there was a couple of questions. If the diver is dragging a cable around underwater to connect the surface for the GPS and Wi-Fi radio signals, wouldn't their location be difficult to track in reference to the location and GPS fix of the floating antenna?
Yeah, so effectively what we're talking about is if we think about simple trigonometry, if I'm at 10 meters and I've got, say, a 15-meter cable, then it could have moved across and it's not necessarily straight above my head. So basically, when you're diving with this thing, having actually done it in the real world, if you're not actually obsessed with just testing it, which is what I'm doing, as you're going around, if you just keep it under small tension, it will be above your head. And at 11 meters, if you look at the trigonometry of it, if I've got 10-meter depth and I've got an 11-meter cable, the amount of deviation you can have is very small. If you look at the triangle and you get your cosines and sines out, it's more of an issue if you're at, say, 40 meters and you've got a 45-meter cable. Now, I'm going to put a 45-meter cable on it, but I would never use it at that depth. I'd probably go a maximum of 20, 25. But it's a good point. So how to think about this, the way that you could do it is if I know the amount of cable that I've unspooled, I know the hypotenuse of the triangle if it's gone off wayward above my head. And then if I know my depth, because there's depth sensor on there. So if I knew how much is unspooled, then I could compensate for that deviation. Well, I have a, what you'd call in sort of GPS terms, like a circle of ambiguity, right? So you've got a circle where you could be anywhere within that circle or on a circle. So what you can then do is something more traditional. about positioning, which is called dead reckoning. And dead reckoning is what sailors would have done, way back when no GPS, use the stars or use any other any reference point, and then you would have to estimate how far have you been and on what bearing have you been on, and then estimate where you are now compared to where you were. Now, because these ESPs have got, the stack has got a 6 degree of freedom accelerometer and gyroscope, and I've got a compass, I was having to talk to my physics PhD friend, and I said, you know your matrix maths, don't you? So what you could do is you could take all these accelerations, which you're getting in real time, integrate them once to get the velocities, and integrate them again to get the distances. We go back to A-level maths. And that would mean that you could estimate, given where the float is and given where the diver is, what's the deviation which is going on. And that's pretty difficult, but you've got 240 megahertz, 2 core processors, and there's 2 of them in the console. There's 1 in the float, but look how big the float is. So if you really wanted to do it, you could put something like a Raspberry Pi in there if you had to. So yeah, it's a good question. It's come up before, so thanks for that.
The other question was around the communication through water between the 2 different modules.
Yeah.
Have you tested that in different types of water?
Yes, I have. I'm glad you asked. So bit of Googling will give you the fact that normally the seawater in the English Channel is 3.5% salinity. So if you have a kilo of water, then you've got about 35 grams or so of salt in there, right? So what I did was I did a YouTube video which showed this is what you get in fresh water, had a bucket, got about 15 centimeters range. Then I chucked some salt in to make it 1%, then 2%, then 3.5%, which is the English Channel. Didn't make any difference. 4%, the Red Sea, didn't make any difference. Red Sea is important because globally it's about the saltiest, except for the Dead Sea. Now, the Dead Sea doesn't count. Because the Dead Sea, if you take a kilogram of water, 325 grams of that is salt. So 10 times more almost than the English Channel. So we will ignore that. And I didn't want to get rid of all my salt supply for next winter by chucking it into a bucket. And then I would have had to probably boil the water to get it all to dissolve. So no, I'm not going to do that. But yeah, that's a good point. Good question. Thanks very much. Do you know what? I don't think it would be very easy. You'd need to have a lot of weight. And when you have more weight, that means it's harder to do the buoyancy. And so, yeah, there's a lot of stuff in the Dead Sea because there's so much salt in there that it's preserved wrecks from a very long time ago. The salinity is such that you've got different types of organisms living there as well, which you just wouldn't see anywhere else on the planet. Bit similar to when you've got volcanic vents underwater, very different environment for organisms to live in. And because it's a closed environment, we haven't exploited the bed of the Dead Sea as far as I know, then it's quite unique.
Cool. Okay. I think the questions that was also around, you did in your YouTube video, the 15 centimeters submerged, only parts of the RF signal might not be propagating from above, not through the water.
Yeah. So if you have a look at the vid, got lead underneath the microcontrollers. So if I just bring it up very quickly, I don't know what I've done there. Okay, very quickly. There you go. Just so happens. Let's just see if I can find the bit. It's going to be 1 byte. You can see that this all right, so that's in air. Now, right, so the point about this is, I did this and I thought, what's going to happen is my Tupperware box is going to be on the bottom of the plastic box. The radio signals can go through a millimeter of plastic, go in the air and then come up the other side. So we use lead weights to counteract the effects of neoprene floating and stuff like that. So a couple of lead weights under there. Okay, they're not 100%, they've got little holes in them, but that's going to stop the radio. And so effectively, I'm sort of satisfied that when I get into the real world and I actually take this in diving, then that is actually only 7 centimeters. But that, if you watch the video, it's 15 centimeters difference. So we've stopped the radio from propagating out of the bottom of the bucket. And then, okay, it could go out the right-hand side and then go around to the left. It's not going to.
Okay, so we have to wrap up now, but just one very quick thing. What was the type of cable you used?
Had a question earlier about how do you keep things waterproof. Go and have a look at Blue Robotics website. They are open source. You can buy an entire underwater vehicle, autonomous vehicle, for $3,500, open source, right? What that means also is you can buy parts for very small amounts. So I bought a cable, which is rated for 300 meters, £6 a meter, which isn't cheap, but it's got specific terminators, which allow you to plug into the box with impunity against water leakage, because they're rated for 900 meters. Astonishing. So the connectors cost £12 and the cable costs £6 a meter. It's 4-core. It's not even twisted pair, I think. I'm at 9600 baud, so I don't really care. And I'm using RS485 to get it down the cable, because if I connected the serial pins directly, it wouldn't have a chance getting down.
Lovely. Thank you very much.
That's all right. Pleasure. Thanks very much, everyone.